Good morning, everyone. A warm welcome to all the participants present here. So let us start our 3-day certification program. Today morning session based on the topics reality modeling, the future for words infrastructures, and it's going to deliver by Mr. S. Rajesh Kumar, Director Technical Sales Tech Apps Consultant, Bentley Channel Partner. Mr. Rajesh Kumar sir is a director in Tech Apps Consulting and a Bentley channel partner. Sir is also an authorized partner for geotechnical PL access and also authorized partners for eTap and ePlan. Sir has 19 years of experience in engineering softwares in sales and training, and also sir completed more than 75 skills development centers across in India academic institutions. Rajesh sir implemented automated softwares learning portals for engineering students as well as faculty and researchers. Sir received a special award by Bentley for conducting more than 200 plus webinars and seminars in the year of 2020 and 2021 in spite of the pandemic situation. I warm welcome Mr. Rajesh sir to deliver the lecture.
Thank
Sir,
you.
thank you, sir.
Can you please tell me the number of participants?
So the participants from all over India, all knowledges and domain, nearly 100, sir. They will joining now.
Oh,
Now
that's
at
good.
present 40. Thank you, sir.
So can we start?
Yes, sir. You can start.
First of all, I would like to thank the Department of Civil Engineering, Structural Engineering, uh, Crescent University. I would like to thank the management of the institute for giving me this opportunity. Um, this year it is going to be my um, 30th presentation, probably on infrastructure. So it really gives me an immense pleasure, especially when we address an educational institute or academic community. It gives me really an immense pleasure to share all the informations, whatever is available with us, and in fact to get some inputs from them is really an interesting fact. So with that as an introduction, I would like to start the presentation. Well, let this presentation be an interactive presentation because I have the entire presentation is filled with concepts which some people may be aware, or maybe have undergone some kind of a sessions on these kind of concepts. Maybe for some participants, it may be a new concept. So please take a note of all the details. At the end of the sessions, we can have a question and answer session so that no, I will try to answer all your questions. Now, so we are going to start with reality modeling. That's our session's topic, and how reality modeling uh, is benefiting the infrastructure industries. In that, we are going to concentrate more on infrastructure 4.0, especially for academics. That is the future of infrastructure. Now, let's just have this as an vision and agenda. Now, achieving better outcomes with technology and system thinking, and building a better educational skills in infrastructure. And Bentley Tech App's future educational programs related to today's topics. Now, especially our session topic is reality modeling for infrastructure. Let me just go and explain what is reality modeling and why we have chosen reality modeling for infrastructure. Now, to be very precise, what is the reality modeling? So, reality modeling is nothing but bringing a real world reality data into your infrastructure projects. creating 3D models out of simple photos of real world imageries. I mean, so now the ultimate aim of any engineers in the infrastructure in their designing phase or in their planning phase is to create a 3D model. Now for creating 3D model, there are so many engineering capabilities, softwares, hardwares available. Now those are complexes. Of course, some are really precise, considering expensive, time consuming. Bentley has come up with a new technology called reality modeling. It has a platform. It creates a 3D mesh. Even you don't have a complex software, you don't have that kind of an engineering knowledge in that particular software, we can easily create a 3D model in minutes. Well, that is, we are using the reality as context to support decision making. Reality means the real world imageries we are capturing. The ways of capturing the real world imageries, we can capture it through our uh, high resolution cameras. If you have a DSLR camera, if it is having high resolutions, those are the input data. Those photos are the input data for this reality modeling softwares, for reality modeling platform. These photos can be a point cloud data. Point cloud data is nothing but you take capture data using aerial imageries. You fly an aeroplane, you capture images. When you want to create a map of a city, if you wanted to, for smart cities, they are creating, big maps. I mean, with the latest data. For that, they are flying aerial vehicles and they are capturing images. When it is in a point, when the output is in point, then it is called as a point cloud data. So these point cloud data can also be an input to this reality modeling platform. So just keep it very simple. If you want to, you create a 3D model out of a simple photos of real world imageries. Simple photos can be a photos created from your mobile phone, your tab, your drones from point clouds data, and you just input this data into a reality modeling platform. That is, we call it as any Bentley's reality modeling software. Then you do some processes. I will explain you on those processes, which are very simple. You get an accurate 3D mesh, you get a 3D model out of it. And what we do with 3D model, we have an immense benefits, especially for infrastructure industry, using, if you create a 3D model using this reality modeling. So for that, you should basically understand the concept of reality modeling. So I'll just brief it out again. Reality modeling is a process of capturing reality of an infrastructure asset. Here I'm just mentioning infrastructure asset. It may be a bridges, it may be a buildings, it may be a maps, it may be a cities, it may be forest, minings, whatever it is. Anything I call it as an infrastructure. So that is the reality of you just capture that physical reality of an infrastructure asset and you creating a representation of it. You collect these data through continuous surveys. Surveys means your photographs or survey data, your drones capture images or survey data. So it's as simple as that. You capture, process, and you reuse the existing reality condition data with our 3D imaging and point cloud processing platform. So that is our reality modeling platform. Here you create actually your digital twin of infrastructure using reality modeling. Now the latest, buzz, in fact, it's a concept just like reality modeling is nothing but a digital twin. Every data is now in a digital format. So you create any of your physical assets, any of your real world imageries, and you create it in a digital format. It is called as a digital twins. These digital twins, the digital data can be used for various purposes as far as infrastructure industry is concerned. Here you actually, reality modeling is a form of creating your real world data and you're creating it in a digital twin format, in a digital format for creating 3D models. Now, so reality modeling is a process of capturing your existing site conditions. So I'm just briefing out in a different verses so that you can understand it. So you capture your existing site conditions using photographs, and I said even it may be a point clouds to create high fidelity geo-referenced 3D models. So let me just show you how all these 3D models, 3D mesh looks like. And assets means assets can be easily documented. A 3D registered infrastructure can be linked to operations and engineering data. Now, these capabilities enable the creation of the digital twin, a digital, up-to-date representation of a physical asset. Now let's just talk about the challenges of infrastructure industries. Then only you will come to know how important and what role the reality modeling platform plays for an infrastructure industry. Now, when you take an engineering data of heritage buildings, like not heritage buildings, any old buildings, there is a lack of engineering data available. For example, if you want to create a 3D model of a 1,000-year-old building, we don't have an engineering data. How to create a 3D model out of it is as simple as that. Reality modeling is the only available concept. You just fly a drone, or you just take a 360-degree of the asset. You take high resolution photographs or a point cloud data, and then you do a 3D mesh, you process using a reality modeling platform. You get accurate 3D mesh 3D model of that particular heritage or any of your old buildings. You don't need to have an actual engineering data, a CAD drawing or something like that. So here, for heritage, for buildings, those kind of buildings which doesn't have the engineering data, reality modeling plays a vital role. You take a complex engineering softwares for 3D model. There are so many 3D modeling designing softwares available, and you need to have knowledge for it. So here for complex, infrastructures, there are n number of softwares involved. For example, if you have a multi-story building, if you create a smart city, if you create an airport design, you need to have a lot of softwares for drafting, for 3D modeling, for for BIM platforms. You need to have so many things for walkthroughs, whereas very simple 3D models can be created for complex engineering structures. And this 3D reality modeling is very time consuming, especially for emergency planning. Suppose if you wanted to plan, create a 3D model for emergency planning. You take any of your campuses, even any of your institute, you wanted to create a 3D model immediately within a day, and you wanted to plan it for an emergency planning. Suppose some VIP is visiting your institute, you can just simply take photographs, plan your the entire campus, the entire infrastructure by creating 3D model using reality modeling. Now you take a transportations, the upgrades and maintenance challenges are huge, in your conventional method of creating digital models of transportation assets. Here the reality modeling plays a vital role. If you take water infrastructure, your development and maintenance of small towns and villages, I'm talking about the assets of water infrastructures. It's really too much complicated. For example, now the Jal Jeevan mission of the existing government, it's their major projects that they are looking out for another 3 years until 2025, and they have invested huge amount of money. There is a huge challenges as far as the assets, locating the assets, maintaining, developing the assets, water infrastructure assets. And the only technology they are looking out is reality modeling, and there is a lack of resources available with many of the companies. And of course, whoever is here and the participants are in the GIS background will know the complex and the challenges available in creating a spatial data infrastructure. It's very simple that that each and every lot of data are locked with the respective sectors. And you create a web-based GIS application of an underground infrastructure is again a challenge. Environmental ecosystems and its maintenance again a challenge. And creating digital smart cities, creating maps has now become a, because those data has to be upgraded on a regular basis. So that is again a challenge. And there are so many construction challenges. I can just list it out. It's more than 100. So here the reality modeling platform has been a vital platform which resolves, which gives a lot of benefits so that the entire architecture, engineering, construction industry can, actually have a creation of smooth digital assets, plan and take a better decisions. Now, as far as reality modeling platform with Bentley systems, we are just representing Bentley, and the platform which is available for reality modeling is, we call it as context capture. So context capture is again a software. It is again, there are software, desktop software, cloud, mobile based software available for context capture. So based on the applications, you can use different types of modules. Now, so let me just go back. If before you begin any of your infrastructure projects, now what the project team does, basically you need a survey existing conditions in order to provide a foundational input for decision making process. That is just to, to understand the context within which the asset will be designed or built or operated. So what are the ways of surveying the existing conditions? Probably, infrastructure people will know that they may be using total stations, they may be using ground based laser scanners, they may be using satellite imageries, high resolution satellite imageries, they may be using some survey maps, especially in India. If it is survey of India maps, you may be using GPS data, you may be using point cloud data captured from aerial mappings. But however, so though there are so many ways of capturing, doing surveys, of course, drone surveys is also there. You just think of technology, where you don't need a specialist. There is no, expensive hardware is required. Yes, of course, these ground-based laser scanners are really, viable. Really, accuracy is there. But if you see the, the cost and the time consuming, it is very much expensive. So, of course, there are a lot of projects have been already executed using total station ground-based laser scanners. Now, but here this reality modeling is a platform which really replaces all these surveying methodologies. However, all these, new technology that takes data capture out of the hands of specialists and makes it accessible to everyone. This innovation greatly simplifies. You just capture of existing conditions since it only requires a standard photographic capture from any digital camera. It may be mounted on an UAVs or handheld. Once the imagery is captured, it is processed photogrammatically with Bentley's context capture to produce a highly accurate 3D mesh, what now we call it as a reality mesh. The accuracy of the reality mesh is only limited by the resolution of source of photography. I mean, basically you need to have some skill in taking photographs. If you are taking photograph of an asset 360-degree, make sure that each photograph swaps with each other. That's a small technology which can be, easily understood. Now, working with reality mesh models, I'll be taking you into a lot of things so that you can understand what the reality mesh is all about and the outcomes of it. A reality mesh models consist of many files, that are assessed as needed during the display process. These things happening, inside the reality modeling platform, that is inside the reality modeling software. We call it the context capture software. The scene of the file with extension will be .3mx. Contains the information about the model. It includes geographic location if that is available and how to access the model components. This basically we call it as a reality mesh, which is the actual process will happen inside the reality modeling platform. Now you see this particular model is produced by context capture in the format called a reality mesh. Now this can be integrated seamlessly into engineering workflow to serve as precise environmental context for design work. Now, practical utilization, the use of reality meshes goes way beyond the design phase. I'm going to show how reality modeling process is being utilized in live projects for construction, especially. Will take drones can be set up on flight plans for continuous survey. Daily models of construction site can be automatically produced. So progress can be monitored, materials located, or volumes of the materials used measured. This record of building progress could be stored and assessed later for as-built or facility management informations. So this, if you want me to explain, so if you see a lot of huge multi-story, communities, kind of a living now in major urban cities, the realtor will construct, will maintain the asset maybe for 1 year or maximum for 3 years. And then after that, they hand over the asset to actual, the buyers, the people who actually live there. Okay. If the people who actually live there doesn't have any information to facilitate that particular building later on, for after 5 years, if they really wanted to refurbish after 10 years. Now, for example, where the generator is, where the firefighting equipment is, where the pumps are, you know so those kind of information, small informations, are not available. So reality modeling here plays a vital role with BIM. Is nothing but the building information modeling, so that for better decision even after any number of years for maintaining that particular asset. Here the reality modeling plays a vital role. Now here, since we are almost into reality modeling, it is very important for the participants to understand what is AR, VR and mixed reality. Now this is a different concept, but it is very important as an infrastructure professional to understand. Now most of them may be using different methods of AR, VRs, maybe through your smartphones, you might be having different hardwares, but just it is very important you to understand the basic concept. Now what is a virtual reality? Now virtual reality, it is a fully immersive, which tricks your senses into thinking you're in a different environment. There is no real environment available, whereas you're thinking in a different environment. For example, you call a virtual reality your PUBG games, your all those games where there is no real world thing is available, and you have some kind of a digital asset. Maybe you can use a head mounted display or a headset. You will experience a computer generated world imageries and sound. So that we call it as a virtual reality. Now, what is AR and augmented reality? The augmented reality is nothing but it actually overlays the digital information on real world elements. So there is a real world imagery is there, your real world environment is there, where you bring in some digital context into your real world. It's called as an augmented reality. You might have seen a lot of applications, apps available in Google um, Play Store. You can see that. So for example, if you see in the left side picture, a pavement he's walking, and if he through a AR app he is bringing in some digital context, some kind of a toy he is bringing in. You can in fact, when you can in fact bring a lot of when you elephant kind of a thing, any kind of imageries. So that's all for small kids ARs available. But when you bring in this AR and you mix with this reality modeling for an infrastructure industry, then the applications are n number of applications available. For example, if you see that picture, in the real context of an industry, you bring kind of a digital informations where you have already created a digital twin information, and you are bringing in that digital twin information to your actual real world. That person is walking in an industry and he is mixing the real world with the digital context. That is called as an augmented reality. Now, this particular video will give you a clear idea of how ARs and RMs are used for infrastructure industry. So that's basically, once such application been used, mixing reality modeling and augmented reality. Now it's very important that you should also know about mixed reality, MR. So AR is nothing but augmented reality, VR is virtual reality, RM is reality modeling, and MR is mixed reality. Here is mixed reality is the integration of real and virtual worlds to produce a new visualizations. Now, where a physical and digital objects coexist and interact in real time. I think most of them might have seen very basic example uh, is your information given in the news channels for climatic changes and other things. Entire concept that used is mixed reality. Probably you better see this video, the total combination of MR and RM.
The 2020 Atlantic hurricane season is underway.
Well, the chance of storms does not end today. We'll be watching severe weather again tomorrow. You could be dealing with a ton of tropical moisture.
What wind and water could some of you be experiencing?
We've got the showers and thunderstorms overnight and into the day Wednesday.
A number of wind and especially water impacts.
How about a weather forecast out here at a drive-in movie theater? We're going to bring up here our big screen.
A system this big is not just going to go away.
So that's your combination of mixed reality and reality modeling. I think now we have a fair idea about reality modeling, the platform, a brief about reality modeling process, a brief about reality modeling for infrastructure, how industries are going to use it. Now, for example, and I think I have also given you fair information about AR, VR, and MR. Now, let's just move on to reality modeling and its applications. Now, for example, here, if you see I'm just given you an information for mining. Your existing topography photo from USGIS, we have captured it from United States Geographical Survey, a mining site. And right side, if you see that existing topography from captured from context capture, context capture is nothing but the reality modeling software. So here, if you see this with context capture data, designer will have more information on the work cost. By using USGS's data, and the work cost would be deficient by 43%. You can see that those things, the difference context capture budget is. So you will have a better, a proposed grading design using context capture topography. In a mining site, You have a bulk, mountain kind of things you might have seen in a lot of thermal power plants. If you want to calculate the volume, context capture again plays a vital role over there. For gradings of mining sites, context capture plays a vital role. Now, this is basically a copy of reality model of A9 Trunk Road in Scotland. I'm just showing you that how these models are used in various industries, domains as its applications. Here, this is for transportation. Now, this is basically a smart city, a Helsinki 3D reality mesh city model with 10 centimeter accuracy. The entire city, there is a Bentley's YouTube channel is there you can go and check all the details about whatever I'm showing right now. So this is basically for smart city. The entire city has been virtually created. In fact, there are plans for 3D virtual parks and even capturing underground and underwater city models. This is one of the winning projects couple of years before. How you can see reality modeling plays a vital role in site planning, in construction industry. So your design starts with understanding the client business need, then your survey, competition, design. You plan your site, create a reality model from photos of the site, evaluate the site future and constraints. You use a BIM platform in combination with reality modeling to plan the site, design the site, your parking, your access roads. Then you continue your design exploration, computational design. The reality modeling platform Bentley very much interoperable with any of the BIM platforms. And you share your design with some visualizations. So you need to have visualization softwares. With Bentley, the product used is Luminarty. These products can be accessed freely from Bentley's portal for having any programs with this, any educational institutes. So if you see any of the supermarkets, it's been completely planned. If you see Walmart or Tesco, they plan their supermarket, where to keep the food materials, for that they do a solar exposures, they do computational design. That way, interior designing as well, reality modeling plays a vital. If you see for walkthrough, they have used Luminarity. For site planning, they have reality modeling software. Yes. I think I have given you enough of information about the context capture, which is the Bentley's reality modeling software that can quickly produce 3D models of existing conditions for infrastructure projects. It is all derived from simple photographs or point clouds. Okay. Let's see how a 3D reality mesh is being created.
Context Capture is Bentley's reality modeling solution that can quickly produce 3D engineering-ready reality meshes using simple photos and/or point clouds to provide real-world context for all types of infrastructure projects throughout the world. Fully scalable and versatile, context capture can be applied to many types of assets at different scales and uses a variety of sensors from laser scanners to handheld cameras or smartphones to produce precise reality meshes affordably with less investment of time and resources. You can combine aerial and ground-based photos to produce an accurate 3D model of your assets, whether it be an industrial site or an entire city. Using simple photos, context capture employs automatic area triangulation, 3D reconstruction, texture mapping, and reconstruction constraints to generate highly detailed 3D reality meshes, point clouds, and orthophotos. Add LiDAR to your photo acquisition when the surface selects texture or the acquisition constraints do not allow for close capture of your target. Leveraging point clouds results in fine details, sharp edges, and geometric accuracy, even when far from your target, such as this substation. Depending on your reality modeling workflow, context capture is available as an on-premise or cloud processing service solution. You can produce 3D reality meshes on your local machine or upgrade to Context Capture Center to save time by employing scalable computing power.
So those circle kind of a things are the positions, photos have been taken.
To speed production of your 3D models, leveraging the latest parallel computing systems. Using a desktop or mobile application, take advantage of context capture cloud processing to generate 3D models without high-end hardware requirements or IT constraints. Context capture ensures interoperability, allowing project teams to easily and consistently publish and share reality modeling information, consumable and accessible, on desktop and mobile devices in many formats, including native use within MicroStation for use in any engineering or GIS workflow. Leveraging project-wise context share, a connected data environment, you can quickly and securely manage, search, download and stream reality meshes and their input sources across project teams and applications. And with a Navigator web application, you can get high-performance streaming of very large reality meshes through the browser to your desktop or mobile devices. With your 3D model, you can accurately measure coordinates, distances, areas, and volumes. Context Capture offers a full reality modeling workflow from acquisition planning through to consumption of your reality mesh in design, construction, operations, and inspection. In design, reality meshes can be used to better understand existing conditions, to help manage the risk of constructability issues and identify potential issues earlier. In construction, reality meshes can be used for continuous surveying and monitoring of construction sites, for change management and documentation. In operations, reality meshes can be used to train new staff on existing assets and operating conditions. These same 3D models can be used for visual operation, allowing owner-operators to easily document existing conditions of industrial sites or factories. The 3D model can be linked to AssetWise or other asset management systems to navigate the reality mesh virtually and to query the database quickly to find a specific asset. Reality meshes can help speed the inspection process and offer higher quality, more repeatable documentation. Additionally, reality modeling techniques allow for easier access to hard-to-inspect locations. Context Capture is the reality modeling solution for creating and sharing highly detailed 3D engineering-ready reality meshes to provide precise real-world context that can be applied to all phases of.
So one important area where reality modeling plays an important role is inspection and maintenance, where it is really difficult to visit that place, do a regular inspection. Those areas, reality modeling really plays a vital role. Now let me just give you a glimpse about producing a reality mesh from a lidar point, clouds, and photos. So here is simple that we are going to create a 3D mesh generation from combination of lidar point cloud data and photographs. It is just a step-by-step operation. Well, in a new project, you are going to just import your photos, whatever the photos that you have taken, and the photos in such a way that it should be, swapping each other. You need to have a small skill for that, and with high resolution things. And then we are going to do what aerial triangulations. Now I'm just uploading the photos. You can see the photos. You can upload photos taken from your cameras, and maybe a point cloud data as well if you have a point cloud. And we can also, in fact, a 3D view the data has been uploaded. Then go back to general tab and submit arrow triangulation. That is very important process in creating 3D reality meshes. Now arrow triangulation is in process. In between, you can add any number of photographs if you have, and then you can add more number of photographs, point clouds. You can again see a 3D view of the uploaded data. Now again, import your point clouds. Now press OK to import your point clouds. You can also review its properties in the right panel. You can select your color mode, scan type, because point clouds are laser scanned data. You can 3D view again your photographs, your laser scanned data, point clouds. The yellow dots represents the position of the laser scanners. Then go to the general tab, create a new construction, create a spatial framework tab, set a tiling if needed, and adjust your bounding box, your tile size. Because it covers larger area, since it's a spatial data, you take photographs, it covers larger area, so you can restrict it to your area of interest. Now you create a mesh. Choose the output format and options. You want 3D point clouds, or there are so many options available. So this is basically the process running on a context capture master, which is a desktop product. Again, you 3D view to review the production results. So you can see the accuracy, the height, breadth after creating the 3D mesh. So it will be accurate. That's a glimpse about creating 3D mesh from combination of lidar and point cloud data. Well, capabilities I have given you enough of information, but still, few things. It consume imagery from many cameras and sensor types. You can create 2D, 3D GIS models, integrate positioning data. It can perform automatic photo block alignments, and you can publish and view web ready models. In fact, you can publish it in any of your GIS applications. It may be S3 or whatever it is. So here it's a small reality modeling for emergency planning. Totally 28,000 images has been captured. One
to capture a 3D model of the city of Philadelphia. By the way, in a what we call a reality mesh, the format that can be used by every engineer of infrastructure in the city, had never been accomplished at all, let alone to accomplish it from scratch in such a short time frame.
Bentley's Context Capture is an amazing piece of software. For this particular project, we're capturing about a detailed square mile. Most of the photography we're capturing is going to be from the helicopter, but of course there's only so close we can get to the objects, the buildings, the important structures. So what we're also supplementing all this aerial photography with is going to be some ground-based photography. So that involves getting very close to the buildings and reconstructing 3D models but from ground level imagery, which will add great fidelity and detail.
World Meeting of Families 2015 was the first time that this event has ever been held in the United States. In fact, it was the whole purpose of the Pope's apostolic journey to the United States. So this was a very large scale event. And what we typically have done in the past is we will utilize 2D CAD drawings and do lots and lots of site surveys. But the ability to leverage this 3D reality modeling was absolutely a game changer for us.
A really important thing was it had to integrate seamlessly, begin to model all these temporary facilities directly in the model without having to go through a lot of translations and import, exports. We just wanted to work seamlessly with.
The amazing thing to me was when you capture these models, it captures the GPS coordinates, so we know exactly where on Earth the models are located. I can tell you 5 years ago, if someone told me this, I'm still having a hard time believing that it works as well as it does now.
Prior to this technology, surveying was something done by specialists once. And now I think where we are, this convergence, if you like, the Internet of Things, where things are connected together. They can be connected together now in the context of a 3D model captured with reality modeling as it evolves, is constructed and operated. And experiment and learn together about this.
The acre site just gives us all the confidence in the world that the next arena.
Congratulations to all who made the event so successful. We think we helped to a degree.
This is a major application which I was talking for emergency planning. Well, the other application is that if you really wanted to have this output of the reality modeling and you just make it as an input into a 3D printer, you get the actual 3D model of whatever your asset is. So here context captures output file format is very much compatible with major 3D printers, whatever is available in the market. Here, you we have just captured. See how capture the asset. So yeah, so you 3D prints again in a is one of an applications as an output for reality modeling. If you really wanted to visibly see the real world contexts in a 3D prints, then reality modeling makes it very simple. So we have something called context capture mobile as well, to make simple things, especially for infrastructure industries. So you just can download context capture mobile from Google Play Store. This is not the full context capture software, but for our mobile phones can't accommodate context capture, the desktop versions of it. So it is a smaller version of desktop. It is called as a context capture mobile. It has been used for inspection, site planning, where you go to a construction site and you just compare your drawings with the developments for class deductions. It is widely used context capture mobile. It's just you can download it from Google Play. It's and again a module from context capture. And then there you create a new project, whatever the project you are working for existing, and you can associate that project with your counterparts wherever they are located across the globe. You can share informations, and in fact you can add new photos, capture photos around your asset. So this is bridge is an asset, maybe for inspection purposes, capturing photos. Based through clouds, it has been uploaded through context capture mobile. Measure a reference distance to set up the scale of your model. Add a survey point to set up the start and end point for your reference distance. When you accept that position, measure the first point in at least 2 images. Accept that position. The second point, you have to repeat the same operation. Scale constraint to define the reference distance. There is edit processing options if needed and submit. Your photos are being uploaded and processed in the cloud. You can also, in fact, review your 3D model when processed. There is a reality data web viewer is there. So can you see that the actual 3D model of the particular area of interest asset? Then wherever your engineers, it can be shared using context capture, share, and then they can download it. They can review using a reality data web viewer. Inspection, development, maintenance, using reality modeling is a time-consuming process. You need not deploy too much of technical resources for that. You can in fact measure wherever the maintenance has to be covered, even if it is a small area, a small distance. A small defect has been captured over here. So this is one, a way of using context capture mobile. How this application is being used in a reality modeling platform. Let me just show you a live application. So if you want to create large scale virtual map that you have to virtual 3D models by high resolution 3D. So natural remote locations, we are talking about planning, maintenance. You can also simulate your virtual reality. You have a Google Elegant lenses. This is smart city planning, flood planning. Reconstructions. Also, in fact, extract the solar activated analysis. Site planning, new reality concepts. We are talking software and open cities with the GIS application. And for aerial imageries, especially in the plant industry. One of these conditions are multiple chemicals and the side to the focus process data looking at that modeling platform using other 3D applications, for example, that create assets which affect so this reality modeling software is very much interoperable with 3D, 4D modeling softwares. One such application is MicroStation with Bentley or other products like, for example, Revit with Autodesk and other products. It digitize the model for development, maintenance, inspection, reconstructions. Here again, it's model for point cloud. So those are some of the applications, live applications using Bentley's reality modeling technologies. Some of the applications uses reality modeling and BIM as well. Now I have just come to the end of the presentation. So all these applications are there, and finally I wanted to talk about our academic program. So our agenda is to set up a VR lab with drones. So we have done it for some of academic institutions, create programs with industry syllabus, and train students and faculties, execute live projects with Bentley's certification. So it's just a everything under one umbrella as far as reality modeling, AR, VR, softwares, hardwares, training syllabus are concerned. So that's it. For any of your queries, you can contact this email, and I have just given you the number. I think I'm done with the presentations. I'm ready to go for question and answers. Any queries?
Yes, sir. Thank you for presentation, sir. Dear participants, any queries, you can raise your hand so I can unmute. You can interact with the guest. Or you can post your query in chat box.
No questions? See, finally, I just wanted to complete saying that there are two major areas of next wave technology. I'm telling you that is nothing but AR, VR, and reality modeling as far as infrastructure industry is concerned. And these kind of programs has created many opportunities in, if you see, in the educational system for effective learning experiences. Now, technology offers new innovative platforms where teachers and students can use communication tools for interaction, discussion, and sharing information. So the entire the learning experience got changed. It's completely a demo-based learning. So that experience changed, and people are the syllabus, the curriculum is moving into a different level of touching upon different concepts, which it's the responsibility of the institutions to create future ready engineers. who are already certified with these kind of technologies. Now, the industry world is awash with data and new information. If you see from sensors, applications, equipment, and people. Now, however, the data is worthless if it is untouched or not used to its full potential to gain insights and make improved decisions. So, now what I'm saying is today's industry using reality modeling technologies to capture existing asset conditions applied together with IoT, and there are techniques like machine learning. The companies can reap rewards of cost saving and improved uptime. So that's it. Thank you so much.
Thank you, sir. May I audible, sir?
Yes, yes, yes.
The participants can leave your queries in the chat box. If you want to talk to the keynote speaker directly, you can raise your hand. We can unmute you.
So someone has asked like, how can we specialize in this any course or anything? Like, so that's what I was talking. I have given you the contact details. You can get in touch with me later on.
Participants, we will share the keynote speaker details to your mail ID, registered mail ID. You can contact him at any time. Ravikumar sir, you can unmute yourself, sir. You can ask the question. Ravikumar sir?
Am I audible, ma'am?
Yes, sir. Yes, sir.
Very good morning, sir. Very good morning, ma'am. Actually,
Yes,
I
sir.
just wanted to ask you, sir, कि जैसे आपने मुझे बताया अभी कि we will be able to do this course for the specialization purpose. So, can we, because we are 21 students in Master in Geoinformatics, and as I already told you, sir, we are pursuing this our fourth semester. So, can we plan to do something, because we have 6 months of project. So, can we plan something in a
Yeah.
project
Yes.
base and do the work with you?
Our ultimate agenda is, asking students to do a conventional projects rather than see. If you see any of your specialized technical institutions, those people are doing some conventional projects. So
Yes,
the
sir.
entire plan is to encourage them, empower them, and increase the talent pipeline in upcoming technologies. So people who are all related to infrastructure, I'm just recommending them to choose reality modeling, VRs and ARs. And I'm here to help you guys.
So,
Ravikumar
sir,
sir, we will share the keynote
So you
speaker
can get
contact
in
details,
touch
sir.
with me. You can get in touch with me, and we can plan how we can design a program for your institution for your students.
okay, okay, sir. Okay.
So any questions, technical questions?
Dear participants, you can leave your queries in the chat box.
Okay, later on you can get the feedback and let me know, madam.
Yes, sir, of course.
So now, thank you so much, participants, and thanks for the organizers.
Sir, thanks for coming for this program, sir. The session was really useful and it's very innovative and you have thrown a light on reality modeling, how to for the future infrastructure, sir.
Thank
Thank you
you.
so much once again, sir.
Thank you so much.
Thank you, Rajesh sir.
Dear participants, be online. The second session is going to start shortly. We are waiting for the keynote speaker to join.
अगला क्वेश्चन।
Dear participants, be online. We are waiting for the keynote speaker to join. There is some network issue with the side. Dear participants, be online. After this session, we will share the feedback link. Even the afternoon, the validation program has been preponed to after this session. We will share the feedback link at the end of the validation program. You can fill based on your names and organization. We will issue the certificate. Please be online.
Ayappan sir.
Ayyappan sir, good morning sir. May I audible sir?
Hello.
Yes, sir. Audible.
Kanadasan able to hear my voice?
Yes, sir. Yes, sir.
Yes sir.
Oh, okay. Okay. My face I will not able to see here. It should be here, no? Good.
Kindly switch on the video sir.
It is not enabling. Not possible to enable that
1
No,
video.
minute
no.
sir.
How to share my screen?
That open share tray is there. No, sir. You click on that.
Show device settings and turn off incoming videos. Enter full screen. There is no option, right?
Sorry. Like square box with the top arrow.
No, it is not coming.
Nearby the three dot is there. No, sir.
Yes.
In that open share tray.
No, it is not enabled. My video and as well as that up arrow is not enabled. Only meeting organizers and presenter can share. It is telling.
Now check, sir. Now
Yeah,
check,
yeah.
sir.
Now it is.
Okay.
Okay, good.
Good morning Ayyappan sir.
Yeah, yeah. I would like to share my screen,
Okay.
but possible to
So
view?
there is one up arrow is there, no sir?
Just a
Top of
moment.
your screen.
Now able to see?
Yes, it's
Yes sir,
coming.
yes sir.
Good. And how it
Yeah,
is?
it's visible.
PPT I want to
You
share.
can go to PPT.
Just a moment. There is no option for entire screen.
Is there sir?
Where it is?
While sharing itself it will ask sir whether it's for full window or PPT.
Desktop. Okay. Now able to see the PPT?
Is loading sir, wait a minute sir.
Okay.
Yes sir. It's
Oh,
visible sir.
okay.
Shall we start sir?
Now, okay. No problem.
The second topic of today's session is on entrepreneurial skills on urban management, and it's going to be delivered by Dr. Ayyappan Lakshmanan sir, Principal Consultant, Mahendran Consultancy Services, Kanjipuram. Now I request Mr. Kannadasan sir to introduce the speaker.
Thank you, ma'am. Dr. Ayyappan Lakshman is Principal Consultant in Mahendra Consulting Services, Kanchipuram, in Tamil Nadu. Sir completed his bachelor degree in Chemical Engineering at Dr. N.N. College of Engineering in the year of 2001, and Sir completed his MTech degree in Remote Sensing at College of Engineering Guindy campus, Anna University in the year of 2005. Sir also did his PhD degree in civil engineering under the uh, remote sensing category in Anna University in the year of 2017. The title of PhD thesis is Identification of Potential Wind Farm Location through Geospatial Information Technology. Sir published 52 research papers related to GIS in international journals and also conducted many GIS training programs like IIT, Anna University, PSG Technology, and many more around the world, including the world, North Korea as a UN consultant. He executed many projects in the research areas like flood mapping, connecting river, groundwater modeling, landslide forecasting, wind farm site selection, solid waste management site selection, water pipeline maps, etc. And planimetric and topographic mapping, e-governance and healthcare JS projects, underground pipeline network mapping using GPR, election swamping analysis maps, web-based bus route mapping, power transition line, network maps, etc. Thank you, sir.
Yeah, thank you very much,
A
Mr.
warm
Kamal.
welcome to this program, sir. Now I call upon Dr. Ayapan sir to deliver the lecture.
Great morning.
Yes, sir.
Actually, I would like to share my work experience. You can see the number of slides what I prepared for here, only 4, right? So, instead of theory, we have to understand the practical concept. Then only we can grow any industry or less entrepreneur skill. That is also to sell our skill to get some revenue to survive in the world. So that is my agenda. So theory part is very less, and practically I can show some more detailed information about urban environment. What are the data we have to prepare, and what are the skills required for the same? That and all we can understand in this session. So, what are the software we are going to use for this purpose? QGIS, that is open source software. No need to spend a lot of money on that. So we can use that software. We can prepare, we can modify the code according to our requirement. We can add on some plugins along with existing software. Like that, so many things we can develop, we can use that software. That is free. That was my motto in the year of 2008. I learned the software. Initially, I conducted in IIT Madras a training program. Then I seeded the software in India. Then it was spread all over India by IIT professors and other learners from me. So that is very useful thing in my life I did for developing used this software and seeded in India. So that is two things. And here in our scenario, urban management. If you take any urban environment, it may be municipality or whatever, corporate, whatever, corporation, municipality, corporation. So these are the division may be there. There may be a town planner, surveying division, revenue section, public health section, and engineering. Okay, so engineering section. Just a moment. Okay, so engineering section. So these are the sections. They are doing lot of work for that urban area. Initially, what are the thing we must understand here? As a geospatial consultant, I supported all of these sections by so many ways. So town planning, if you take town planning section, what they are asking, I want to know the boundary of that municipality limit or whatever, and individual ward they split for managing administrative purpose. They split that entire boundary into according to population. They split small wards. Some municipality may be 2000 to 5000 population per ward, it may be there. Sometimes it may change according to the boundary. Here, how we can split this ward? We have to support them for town planners, street wise census data, and how many people living in that street. According to that, we split that ward. That is a big task. Then surveyor also. What is the survey number for that particular land? They may be having different maps. I'll show you one by one. Here I am taking, this is Delhi municipality. I'll move what work I carried out in Tamil Nadu. Okay. Initially, what they are keeping, the old maps. It may be a rough sketch or based on survey numbers. The map was prepared by using CAD software or whatever. So we have to bring to geospatial environment. So you can see the shape of the paper, how it is looking like. We have to bring that. That is a task. Bringing on geospatial environment. Then the sheet we have to bring. That is also one of the tasks. We have to support the town planners. Then wherever park area, we have to mark by using satellite imagery or GPS survey. What are the revenue villages around our municipality? That also we have to prepare maps. Then we split this entire municipality into 36 wards. According to population, split, not equal area. You can see number of people living in that particular ward almost equal. According to that, we split that. We have to support to town planner in that aspect. As well as what are the assets handed over by the public. So park and bus stand and bus station, railway station, so many assets are there. Some other than railways and park area may be handed over to our municipality. So they maintain, they develop for vegetation as well as some other uses. It may be if they want to construct some public toilet, they can use that kind of land, and construct some water tank. They may be utilize that open area or whatever that kind of public land assets of the municipality. So if you take the assets details, what kind of asset, what is the survey number of that asset, you can see what purpose we are using. These are the database we have to prepare for that town planning division. Area of the asset and who is the owner of that asset and nature of that asset what we are using: park, bus stand, burial shed, vacant land, daily market, compost yard, saluters, and Adobe Kana. Like that, we use that land. That information we have to prepare where it is exactly located. We have to do the survey and we have to mark by using GPS. Like that, we have to support for town planning people and assets. After that, road also we have to maintain, right? This is a town planning section, how they are maintaining the boundary. They mark the boundary, and in that boundary they split the wards according to the population, and what are the assets present in that municipality they marked, and they added the information about the assets, that also added. So then after town planning, now we can move for public health, another division of um, municipality. You can see what are the locations the common toilet already constructed. You can see CT means common toilet, location of the common toilets according to the wards. Okay. You can see each ward has how many common toilet. At least one common toilet must be there in a ward. Like that, how many wards are there, how many common toilet, public toilet, and already constructed, needs to be constructed. Like that, for analyzing purpose, these informations are surveyed by using GPS and mapped properly. Also, the seat capacity of each toilet also we have to mention, we have to add as a information. Like that, we have to do survey. Then hospital locations, temples, to maintain clean, the temples must be maintained by clean. Market area also must be maintained clean. So for that, to identify any festival time or temple to be maintained properly. And hospital locations, wherever hospitals are there, public health centers, urban public health centers, that also should be maintained properly. For that reason, here we did survey for that entire municipality. What are the locations, common toilet, school, and temple? Like that, we prepared map. So this also one type of entrepreneurial skill to understand the geospatial data. And ward number also it is displaying, and MCC, micro composting center, wherever micro composting center, and how we can here we split some zones. They used battery operated vehicle, and other area they used some other vehicles, cycle, rickshaw, like that. So like that, they split it into zones. Each zone has some MCC, micro composting center. That also we prepared by map. Salutar locations, what are the facility available in this municipality. So here how many area that layer and common toilet female, common toilet both, common toilet female both, boys both male female both, like that we have to classify. And the seat capacity also we should show, right? Other than this, other facilities are there. Just a moment. Temples. Okay. After that, they classified MCC zones. Each zone has MCC unit. Some shelter-like structure, so that composting. They are converting organic matter into compost, like fertilizer. It is happening here in that centers. So how many MCCs are there? That also listed here. MCC locations, here MCC 2, like that, MCC 3, like that we mentioned. That also important for them. After that, burial ground locations, public toilet with symbols. We prepared that map. Okay. So after that, street lights. MCC. Street lights. How many streets, how many lights are there, you can see for our understanding purpose. Each street has lights. That also we picked by using GPS and prepared map. Okay, nearly 3000 points we picked up. If I enable this road, then you can understand road network. Okay. Okay. Each of the light pole was surveyed by using GPS. Then we prepared map. Type of light, LED or LCD, whatever. So we have to mention our sodium vapor light. When they install that light, like that we can add n number of information about the light pole. Then we can move for water supply. So wherever pipelines are laid and diameter of the pipeline also we have to uh, show here as a label. So PVC pipe 75 mm, like that. Other type of pipe, DI pipe 250 mm, like that mentioned. As well as public tap. Wherever public taps are there in this area, that also we prepared, we surveyed and prepared map. Then value locations. Here each water tank and pipe, feeder pipe as well as distribution pipe, distribution main. In between so many values are there from the OHT location. So that values, how many values are there, that also we marked on the map for understanding. So how many values are there? Nearly 407 values are there to manage 17 OHTs constructed overhead tanks, and values are there. Then here pipeline, length of the pipeline, as well as we can see that information. What are the information we have to add? Pipeline in terms of inches. While collecting the data, they tell in terms of inches, and ward number and the name of the street, like that, carriage and point type, like that, type of road, bituminous road, concrete road, paver block road, like that, and whether it has drainage or not, like that. We have to add n number of information for the pipeline. The road information also we should add. After that, they want to lay new pipeline. We have to tell each starting point of the pipe and the ending point, what is the elevation. So which direction water can move, whether through gravitational or against gravitational, that you can understand. Here the starting point of this network 96 meter, while reaching the 94. So through gravity the water can move 2 meter, elevation differences are there. Like that we can understand. So you will not face any issues on whether the water reached to all the part of the town or not. That can be easily you can understand. Similarly, hydraulic analysis, some other techniques where the pipe pressure is more in the pipeline network, that also we can analyze, and optimum diameter of the pipe, how much diameter is actually required for that particular location, that also you can identify by using some uh, uh, softwares like eParnet, some gems, water gems, like that. That kind of software can be used. That uh, that also we can bring into QGIS environment. We also can do that kind of work, hydraulic analysis work in this water pipeline, where more stress may be there, where a lot of problems are coming, where the pipe is bursting, like that we can understand easily by elevation details along with hydraulic analysis. Here what are the locations of tank, how water is moving, that we can understand, which time which valve have to open and close, that also we can understand by geospatial technology. So these are the requirements they are asking from most of the municipalities. We want this map uh, for understanding the entire pipeline network, like that. Elevation of the each junction of the pipe, that also we mentioned, that was created by digital elevation model. Then valves, water pipes, and number of water connections. You can see 42,000 water connection provided in this urban area. You see 42,000, 43,000 almost. So each in front of each house we have to pick a point whether that house has toilet facility or water connection. Both we have to do as a survey. Like that we prepared this map. You see how many points are there in each area, how many connections are there. Okay, in that whether toilet also we collected, that house has toilet connection or not. You see we recorded this through GPS. Toilet, this is water connection, yes or no. So toilet, whether it has, that house has toilet connection or not. So you can understand what are the houses does not have toilet facility, that we can showcase here as a different colors, that and all already You people learn from my previous authors or session handled people like that. You can see. So here no toilet facility. These people has toilet facility. Like that we can symbolize, you can discriminate the colors. Most of the houses having toilet facility. So other houses here, these are the areas we have to help them to construct any public toilet or not. Where we could construct more public toilets, the houses, those who are not having toilet facility, in that area we should identify by using this kind of map. For that purpose they ask. Okay, so now you can understand what are the areas uh, not having toilet facility easily. Okay, so this area newly developed slum area that we need to focus. Like that we can understand what are the data we need to prepare, how many hours, how many manpower required for this 43,000 point data to collection in front of every house by walking. We will not able to use some other vehicle. Every house we have to walk. Then transportation and road. Road is just a moment. Okay, road. A road network you can see whether bituminous road, cement concrete road, pavers block road, and WBM road, earthen road. That has been classified. That also classified length of the road also we calculated, and this classification we have to move to the road, and we get so many information. We can see here how many information. So name of the road, length of the road, unique line, and the road belongs to which ward, and any other name, carriage type we have to give that CCBP like that. Unique ID we have to generate like that. We prepare n number of information, whether that road has drainage or not, starting point of the coordinate, everything we should provide as a ledger. Okay, like that, whether it has drainage. So drainage color you can see each road whether it has drainage. You're not able to view here. As per their guidance, I prepared this color. Now we can change the color. You see, wherever this dotted lines are appearing, that road has drainage facility. Other roads does not have that facility. Now, where need to construct drainage? Clearly, we can understand what are the roads are having drainage facility or not. Similarly, water supply, what are the area as pipeline network are not having pipeline network, that also we can understand. Now you can see how clearly it is visible, we can understand. Then important landmarks like that by using this satellite imagery. It's taking little time. Okay, we prepare all the road network, build up area like that. You can see the buildings are captured. All the buildings were captured. Whether approved buildings or unapproved buildings, that we can classify. Whether they paid the tax or not paid, that also we can classify. So DDCP approved buildings or not approved buildings, that we can classify very easily. Tax paid for 1 year or 2 year, pending for 1 year, 0 year, or already paid 4 years pending, like that. If we have the information, that also we can collect and add here, that we can host in the website. So to understand the people, those who are paid or not, how much revenue we could get within this month, like that we can achieve some targets. So already I told you, supporting for town planners and surveying division, revenue section, public health, and engineering sections for road construction, drainage, sewage. So all the aspects we could support. So we want some skills. Either we must have knowledge about surveying and GIS concepts. We could survey in this field. So that is the motto. Here, what are the in future they are moving towards smart city development. For that, what are the people required? GPS survey as well as GPR survey, POI collection, GIS database creation and analysis, WebGIS, WSN, wireless sensor network with GIS, flood map or some other disasters. So many ways we could support. Then one more thing I forgot to tell. Here you can see this urban area is located here. The water source you can see more than 100 kilometers. This is pipeline network. This is old scheme. This one is new scheme. Nearby Valley, 50 to 60 kilometer far away from that urban location in Tamirapani river at the point of Sivilaperi. So we are bringing water. This pipeline network also I prepared as a map wherever it is moving, and number of air valves and shower valves, that also identified. So in water distribution network, shower valve as well as air valve, both are very important. So the peak point of the network, that means it's a water network. So source is OH tank. So where it is the peak point with this junction 98, 97, like that. If you see peak point of this network, we can install some air valves and scour valve, that is for cleaning purpose. After supplying of water, the water has some sediment. In that sediment may be storing and lower elevation of the pipe, that we have to clean that sediment. For that purpose we kept scour valve. By using that we can clean that water and sediment properly. That location is lower elevation of the water pipeline network, lower elevation. That location identified and install that scour valve. These are the technique. That is also very important. So these are the ways I supported for this municipality. What are the things required for them? I prepared these kind of maps and supporting for many divisions. This is my job I am doing. So you people also interested, you can develop more on that WSN with GIS, that is upcoming field. Everything should be controlled by wireless sensor network. If I want to open a valve, that can be controlled by sitting one place, that valve should be opened through wireless sensor network. By using our mobile phone, all the valves should be operated, and all the pumps should be operated. All the electrical lights may be operated. So many ways that WSN maybe use upcoming future. Most of the country they are adopting. Now our country it will take some time. Similarly, flood hazard maps. So most of the urban area in the world may be developed nearby river banks. That we know. So river bank means most of the people living on river bank area. Definitely they may face some flood related issues. So we have to prepare flood hazard zonation map, where if rainfall occurred in this water basin, it may be 10 to 15 mm. How much water may flood may come this urban area? That also we could calculate by using some software along with this QGIS. If they are providing their support, we also can develop that kind of model. It would be very useful for people, those who are living in flood inundation areas. To manage that area, we required flood hazard donation map. Already I told, I explained 3 or 4 concepts that required for urban management. One is flood, another one is hydraulic analysis, and GPR for identification of pipes already laid pipe. It may be 20 years, 30 years before we laid some pipes. Now we can understand what is the depth of the pipe and the location of the pipe by using GPR. In that way, GPR technology also we could adapt. We can support for urban management. As well as one more thing I forgot to tell, prediction of future land use changes. How the urban area can grow, that also we can prepare some maps by using GIS in future. Based on the past events, we can tell this urban area can develop in this direction, this area, like that we can identify. So in these are the ways we could support the urban people, urban management sector. It may be municipalities or municipal corporate, whatever. Then I will show you some Delhi data. Issues are different from this small municipality. Delhi metro trains, airport, and drainage system, everything is different. Bus stops, so many facilities have to provide to the public. You can see number of bus stops, road networks, metro trains, and streets, street lights. The complexity is more according to the population. You see river locations and metros, how they planned this area, how they developed beautifully. You see outer of the Delhi, while inside it is different. The old Delhi may be differ. You can see here also they prepared some hexagonal shape. Like that, the planning of that urban area and metro train stations, public toilets, how many toilets, like that we can understand little. Now you can see here what are the information we should provide. Here already we discussed some fuel stations, tree locations. Bio cover is very important. I didn't discuss there in Kovilpatti municipality. Now Delhi. All we know, we are reading about Delhi pollution. So number of vehicles increased, pollution also increased. So no one is telling number of trees decrease, not adequate number of trees we planted. Because of that issue, pollution is more in Delhi. That also population density. Number of people living in Delhi is uh, very huge. It may be in terms of crores. How we could manage that floating population? That also more. How could we supply water? How could we manage sewage? How could manage drainage and other issues? So that is difficult task. Similarly, you can see now upcoming or developing areas or how it is looking like. There is no proper planning. So already planned area with proper approval how it was developed. So we will not face any traffic here. Any traffic in this road, we can move that road. Like that, they developed road network in this Delhi, this area. Like that, planning as well as developing in so many aspects. We need geospatial technology. If you learn this technology, so many dimensions are there. Most of our Amazon, Flipkart, they are running business by using GIS technology. If we order any product here, okay, so how they can deliver nearest point of the product, like that they are searching. Similarly, in urban management, so if you want to lay new pipeline, so nearest point, shortest path, that also we can analyze by using geospatial data. So most of the department which present in urban management, this GIS technology can support in so many aspects. Okay, so you people can ask some questions, so I will be answerable for that. Any questions?
Dear participants, if you have any queries, you can post in the chat box, please.
Hello.
Yeah.
Hello. Yeah, sir. This is Sagar from GNIT. I am a research scholar. I want to do flood modeling, urban flood modeling, and I'm
Okay.
currently using QGIS and WRF hydro model. I want to know that with QGIS, any other software that are free of cost that can be utilized with QGIS to do urban flood modeling. Can you suggest me any such software along with QGIS?
Yeah, SWOT model that also you can use.
Okay.
SWAT, SWAT or river, river. Okay.
Yeah.
So you can move to manage plugin. River GIS is there, no? You can use this software to prepare flood model.
Okay. Okay, sir.
Okay.
River GIS. Thank you, sir. Yes, sir.
Okay. So any other people having any doubt? So you people can ask about this software. I am traveling with this software more than 15 years. Okay.
Sir, one more participant
Yeah, please.
from Rajalakshmi ma'am. What type
Okay.
of modeling can be done in transportation?
Transportation, I didn't try anything, but I worked for Tamil Nadu government. Police department asked me where we can keep, how we can avoid accidents, and where we can keep barricade like that. This kind of question they ask. Why the frequently the accidents are happen like that? They asked me in that NH Bangalore highway. So I recommended and suggested. I did some little project for them. Okay. So there is no particular software for that. I didn't try. So if required, I will check and let you know, please.
Sir, another one, what is the cost of the software? What kind of, or it's free
No,
software?
whatever I am suggesting, all are free. So I never go behind of any proprietary software.
Another query from Gauri ma'am. Heavy metal contamination in groundwater, any software available for that study, sir?
Heavy metal contamination, we can prepare some distribution map, or by using cross validation, we can verify that how much accurately the contamination occur. That we can suggest only by interpolation techniques. So many interpolation techniques are there to identify, no, to find accuracy level. So which method may be adapt for your study area may vary according to that. Already I worked some water quality analysis related work. You can check in that Google. So many papers I published, so that you can understand how we can do cross validation. That and all you can understand.
So one more from Rajalakshmi ma'am. Can I get the details of the project you have done, sir?
Already I told you people can search in that website. The published papers are there. You can go through. If you have any doubt, then you can call me. So already my number I displayed in that first screen. How many of you noted down or not? So 9047134181.
Any queries from participant side?
Please ask your queries. So any area of geospatial, any vertical or horizontal.
So one query from Abu Libda. How can one benefit from urban GIS maps in climate resistant planning of future cities?
Climate and here urbanization means most of that concrete buildings we are constructing. So it may increase the local temperature. Already proven studies in Neyveli, Lignite Corporation, they developed, they planted more trees. The local temperature is differ from other areas. So if you plant more trees, the temperature may be in our control. If climate change, most of that stones we are converting, crushing into sand, we are using construction, and cement we are using construction. Concrete concrete blocks we are developing in urban area means we may face climatical changes. So that is happening everywhere. Most of the people not living in any hut or somewhere, they are living in concrete houses. We are dumping concretes in particular one particular area. The local temperature may vary, as well as the climatical change default it may vary.
Participants can type your queries in the chat box or raise your hand. If you want to talk to the keynote speaker directly, you can unmute yourself and you ask your query.
So I already prepared some flood map for 2015 flood. It was published in Tamil newspaper. Full of 2 pages they published. Now you can see elevation, affected area hatched here. So I prepared that purpose. Don't purchase any land in this area like that. After 5 years, I checked this same map. Most of the development happened only this hatched area. So there is no use of this map. So most of the people, you can see same area again it is affected. Here also, so many area again it was affected this year flood also. Like that. So flood map. This entire Chennai, Greater Chennai. It is not only Chennai, Greater Chennai. That entire area DEM map, DEM digital elevation model was prepared, downloaded from the Bhuvan website, and we prepared this map. And reporter also suggested these are the area affected like that. So these concurrence I prepared this map. So this setting is different. So should not follow that. Like that.
Sir, one more query they asked.
Yeah, please.
Which GA software is best suitable for overlay analysis?
So any software suitable. No issues on that. What I'm suggesting, if you learn any one software, if you if you learn one software, you can work any other softwares. No issues on that. If you learn cycling, BSA cycle, you also can ride Hercules cycle. No issues on that. Like that, if you learn one software clearly, the tool may be here and there. They shuffle the tools only, but the concepts are same for any software. So my understanding, I'm telling. I also used ArcGIS or so many softwares or Map Info, whatever. So everywhere the concepts are same: data creation, editing, and updating, displaying, retrieving, like that. You people aware of this GIS already? The previous session maybe they handled. So my concern only three letters: GIS, geographical information system. What is geographical? The features on the earth surface, below the surface, above the surface, all are geographical features. The features having geographical coordinates. It may be your building, it may be your light pole, it may be any location. All features having geographical coordinates. So we can call the first two letters any features on the earth surface, location of the plant, and footprint of the some landmarks, like that. Any features, buildings, road, water valves, so many features. What are the things we have seen? That and all geographical feature. Information about the geographical feature. Suppose if it is a tree, name of the tree, age of the tree, like that. If it is a pipeline, name of the pipe, type of pipe, diameter of the pipe, who laid the pipe, when they installed, depth of the pipe, like that we can tell in information. If suppose a building, owner of the building, area of the building, who was in charge, who was engineer, when they constructed, like that you can tell n number of information, type of building, concrete or hut, whatever features on the surface, earth surface, you can tell information also. Without information we will not find any feature, like that. Similarly, system means there must be a input, there must be output, in between there is a process. So what is the input? What are the inputs? It may be satellite imagery, rough sketch, and aerial photo, drone photo, CAD data, and already existing topographic sheet, whatever. These are the inputs. And output, maps, analysis result, so many forms. Process, what we are doing in the software. So only three letters GIS for simple definitions. Okay, any other query? Okay, so I am also very much interested in research. Those who are those you people want to do some research, so you can consult me whenever I free. We discuss. We can bring your research in proper shape. Okay, I also can help you. Okay, just a moment. Hello. Okay.
Yes, sir. Another query.
Okay.
Could you please comment on the differences in accuracy between different GIS software products, which might cause different quality of results and therefore can be a challenge for the users in selecting the software that is appropriate for the intended application?
No, you will not find any difference in accuracy, any software. Accuracy is depending on your interpretation skill, not based on the software.
So which version latest QGIS you are using, sir?
So latest version, you can see here help section 3.22.3. So I'm using every day it is updating my software. So there that kind of thing I'm using. I can update whatever the thing they are updating in that source code. I also can see. The developers, they are developing the software, they are updating every day. If I night build software they are calling, if I want to update every day, I can do that. So updated version I can get. Good, you people are asking nice questions.
Dear participants, any more queries? Please interact with the keynote speakers, he expertise speaker. So clarify your doubts based on your research area on GIS.
Participants, any queries? Ipan sir, no queries from the participant side so far, sir. Ipan sir, are you there, sir? Icon sir, thank you so much for coming for this program, sir.
Thank you, madam. Thank you, Kannadasan.
Thank you,
Thank
sir.
you,
Thank you,
participants.
Thank you, sir.
Okay.
Thanks for
All the
accepting our
participants.
invitation, sir.
Nothing, madam. Nothing, madam.
Thank you,
You are
thank you,
sincere.
sir.
You are sincere in work. So you both. So that is the reason I joined here. Okay. Thank you very much.
Thank you so
Thank
much.
you, sir. Thank you.